Okay, so welcome back. Here's another interesting special form. This one is the sum and difference of two cubes. And this time you have to remember how to find a perfect cube. And it might be helpful, by the way, as an exercise, to remember some of your numbers in cubed form. And we can do some basic ones. Let's talk about this. We recognize, for example, let's review. 1 cubed is simply equal to 1 times 1 times 1, so it's just 1. 2 cubed is 2 times 2 times 2, and that's 8. 3 cubed is 3 times 3 times 3. If we do that, we get 27. 4 cubed, 4 times 4 times 4 is equal to 64. 5 cubed, that's right, if you're thinking 125, that's what it is. If you know your cubes up through 5 by memory, that's usually pretty good. Most people do that. It gets a little bit harder once you get past 5. So, well, let's leave it right there for now. Let's take a look at our difference cubes. We're going to use this format. It says whenever we've got the sum of two different cubes, that sum is equal to, in factored form, a plus b, that's the cube root of each term, this binomial, and then a trinomial formed by the square of the first term minus, if it's plus, the product of the two terms plus the square of the last. And for a cubed minus b cubed, very similar, except a minus b times a squared plus ab plus b squared. And a good way to remember that is to know that whenever you've got a sum or difference of two cubes, then you should remember that the a and b always stays the same. We've got a binomial with a and b in it. We keep the same sign in our binomial, but then we also change the sign in our trinomial for the second term, right? So in this case, same sign, opposite sign. This is always positive right here. I've heard some people use the term SOAP to remember that. Same sign, opposite sign, always positive on the last sign. If that helps you to remember it, well, enjoy. All right, so let's talk about this. We've got x cubed plus 64y cubed. Which one is this as an example of? Well, probably that top one. In this case, x cubed is certainly a perfect cube term. How about 64? Well, referring up to our values up above there, 4 cubed is 64. So this is really the same thing as 4y cubed. All right, so when we factor this, what should happen? Well, using our top model right here, a is being replaced by x, b is being replaced by 4y. So in our factored form, we're going to get a binomial that includes x added to 4y, and we're going to get a trinomial that is going to be the square of the first term, x squared, minus, right, same sign, opposite sign, minus the product of our two terms, so this would be minus 4 times x times y, plus the square of the last term. Well, 4y squared is going to give us that last term, and this is going to turn into the expression x plus 4y times x squared minus 4xy plus 16y squared. And you should know that this trinomial is prime or not factorable over the integers. All right, so we would leave it, and that would be our complete factorization. All right, how about this next one? Well, 16 is not a perfect square, and 2 is not a perfect square, and we notice that we've got a fourth power here and a b over here. Well, if you don't recognize it right away, you should note that, of course, there is a common factor here, and we should always remember to factor out that common factor. So let's talk about it. We've got 16a cubed b. It looks like we can take 2b out of everything. That should leave us with, let's see, 8a cubed, and 8 is a perfect cube. That's a good thing for us. 2b from 2b to the fourth just leaves b cubed. And so, yeah, we definitely have a difference of 2 cubes right here. So we'll use our model. 8a cubed minus 8b cubed is the same thing as 2a minus b as our binomial factor. And the square of the first term was 2a squared would be 4a squared minus, no, plus, right? Always positive right here, opposite sign, opposite. 4a squared, 2ab, so plus 2ab, plus, this last term is always positive, b squared. And that would be the difference of 2 cubes part of our factorization, but to make it complete, remember that 2b is a factor that gets carried out in front of everything. So that would be our factored form there. All right, one more right here. We've got p cubed plus 64 q cubed. Well, that's really the same thing as this first one, isn't it? Yeah. Well, that means we're repeating ourselves. So I'm going to leave it at that. See example 1 here. But I'll have you try this one at the bottom. We've got 32x to the fourth y cubed minus 108x y cubed. So you get the factorization of that. Tell me what you get. Answer in the next video.